Hi friends, how are you today? I hope you're having a great day. I am here to teach you some math, and if you can believe it, this is the very last thing I have to teach you in math for fourth grade. We have come to the end of math. We've already finished science. We're finishing word study this week. We're almost near the end of everything else, guys. We are so close to the end, and we are so proud of all the hard work you guys are doing during digital days. We know that it can be tough, and we're just really proud of you, and we don't want you to give up. You're this close to the end, so just keep pushing, keep working hard, and we're almost there. So, as I teach you today, which is kind of going to be a review of something we already did in third grade. I love it when that happens. So we're going to kind of teach review a little bit this week and then move into some more problem solving. Maybe later this week, but definitely next week, which is our last week of full week of learning. So you need to have open your line plot slides, and you can see several learning targets on there for this week. The first one says, I can make a line plot to display a data set of measurements and fractions of a unit. So for example, halves, fourths, and eighths. And that's going to be one thing different that we did not do in third grade, is using fractions on a line plot. So I'm gonna model some of that for you today. You're gonna actually practice without fractions today just to get you back in the swing of putting together a line plot, and then I'll let you guys practice some harder ones later in the week, but today's isn't too hard for you guys. Then also we're going to be solving problems, including addition and subtraction of fractions with common denominators by using information presented in line plots. So that's when we're going to review line plots. We're going to make some. We're going to look at some today. And then the next couple of times we do math, we will start getting into some of that problem solving. So if you would like to pause this video and go do your estimation 180, be sure you think of some estimates that are way too high, some estimates that are way too low, and then some estimates that you think could be correct. So pause this video and then come right back. Okay guys, so click onto your first mini lesson slide, and it says, what is a line plot? Now when you think of a line plot, when I think of a line plot, a number line pops in my head because it's very similar to what we see when we work with regular old number lines. So a line plot is actually a type of a graph. So like a bar graph, a pie graph. This is just another type of a graph. And it shows us the frequency of data. So how many times we have a certain piece of data, and it's shown on a number line. So it's usually better to use a line plot when you're comparing less than 25 items. You don't want too much data on a number line. If you have, line plot, I'm sorry. If you have a lot of data, there's other types of graphs would probably be better. But this is a really simple and quick way to organize data. So on this slide, I have two examples, and these do not have fractions. These are just to remind you what a line plot, I keep wanting to say number line plot looks like. So if you look at the first one, you see at the top a title. The title of this line plot is candy bars. Across the bottom, you see number of candy bars, and you have the least number to the greatest. And in this case, the least number of candy bars is 0. The greatest is 8. When we make our line plots and start to organize data, it's important that we think about the smallest or the minimum number that we need on our line plot, and then the biggest, which is the maximum number we might need on our line plot. Now, going vertically like this on the side, you see number of students, okay? So the X goes to show you where one student was. So perhaps this is how many candy bars students got when they were trick-or-treating. We don't know exactly. But the X's show us how many students represent each number. And now for this, we don't have a key, so I'm going to assume that 1x equals 1 student. Okay, so let's pretend it is how many candy bars you got when you went trick-or-treating, or these students got. So we see that 1x above the 0, that means that one student got 0 candy bars. Okay, that student didn't get any candy bars when they went trick-or-treating. If you look at the 1 and the 2, you also see 1x above those. That means again that one student got 1 and one student got 2 candy bars. All right, now when we get to the 3, it's a little bit different because I have 3 X's. That means that 3 students got 3 candy bars. Okay, 4, how many got 4 candy bars? 0, there's not an X there. So no student got 4. And just keep on going through the rest of the line plot. We see that 3 students got 5, 2 students got 6, 1 got 7, and 2 got 8. Okay, so this is an easy way that data is organized. We can look at it. We can already start to tell. We can see which one has the most X's or which one has the least X's. And those kind of things will be helpful for us to notice when we start solving problems. All right, if you look at the next one, you see that the minimum or the smallest number on this one is 26, and the maximum or highest number is 33. So this is an example that line plots do not have to start at 0. They have to fit the data that you have. And if it's something like number of students in a classroom, you're not going to have 1 or 2 students in a classroom. You're going to have bigger numbers like 26 or 30, okay? So if we look at this, we can quickly see that 0 classes had 28 or 32 students. We can see that 1 class had 26, 1 class had 31, and 1 class had 33. You can see that 2 classes have 27 or 30 students, and you can see that the most common number of students in a classroom in this data set is 29 because 4 classes have 29 students, okay? So those are just some examples. You can refer back to these if you need to as you do your work. Let's look to the next slide. Okay, so Mrs. Baker's cooking class is making long loaves of bread. I started thinking about like a Subway sandwich and how delicious that would taste. Oh, I miss my Subway sandwiches. Maybe soon we'll get to have one. But that's the kind of bread I'm picturing, these long loaves of bread. Now, they measured the loaves and recorded their measurements. And the unit for this is yards. I forgot to write it when I wrote those numbers out and took the picture. But we're talking about yards. And if you remember back to measurement of distance or length, a yard is about the same as 3 feet. I think we did one of these last week. Which again is about the space between the doorknob on a door in your house to the floor. Okay? So this is our data. These are the numbers that we're going to put on a number line. And this one we have shifted into fractions. Now, if you look at these fractions, hopefully you notice that all of them have the same denominator, which we know makes them very easy to work with. So I can just look and I can see, I only see 1 1/6. I see 4 3/6. I see 1 2/6. I see 3 4/6 and 1 6/6. So I'm going to think, what should the smallest number on my line plot be and what should the biggest number? And I'm thinking, because all of these fractions are 1 or less, the 6/6 is equal to 1, I'm going to think 0 to 1 would be a good range for this number plot. All right, if you click to the next slide, you'll see these numbers now on a line plot. So each one of those data points is now an X, and it's above the length for that measure of the length of the lengths of the loaves of bread, okay? So you can see that 1 loaf was 1/6 of a yard, 1 loaf was 2/6 of a yard, and 1 loaf was 6/6 of a yard. We also see that 4 loaves were 3/6 and 3 loaves were 4/6. That's kind of confusing. Okay, we're going to come back to this line plot later in the week and do some problem solving with it, but for today we are just setting up line plots. We're taking data, putting them on line plots. So now we're going to look at one that's a little trickier, and I'm going to model it for you and then show you what it looks like when it would be finished. So click to the next slide. This one is a little trickier. If you look at the data in that chart, you might notice that these fractions aren't as nice and neat as the ones on the last one. They do not all have the same denominator. Okay, so I'm going to have to do something to these numbers to make them easier to work with. Okay, so I'm going to have to find a common denominator. I'm going to have to think, what do I know about these fractions and how can I make them have the same denominator? So I'm going to talk you through it on the next slide, and then I'm going to show you on paper behind me in just a second. So the denominators are 2, 4, and 8. Now, those are really not that hard to work with. We can change them around by just doing a little multiplication like we learned back in the classroom. And if I think about it, I know that 2, if I multiply that times 4, I get 8. So I can change a denominator of 2 into a denominator of 8 by multiplying the numerator and denominator by 2. I'm sorry, by 4. I think I said that wrong. 2 can be multiplied by 4 to get 8. 4 can be multiplied by 2, okay? So I also know that 1/2 is the same as 4/8. That's going to help me on this. And then if we know that, we know that a 4th would be 2/8 because a 4th is half of a half, and 2/8 is half of 4/8. And then going the other direction, we can think that 3/4 is the same as 6/8. Okay, I know this sounds kind of confusing without seeing it on paper, so I'm going to work on it up here on the wall now. Okay. All right. So I want to think about the minimum and maximum length that I have in this problem, and that's going to help me decide how to set up my line plot. I think the biggest number I see is 1 because I don't see any improper fractions. So all of these fractions are going to be between 0. Oh no, I chose a bad marker. Let's see. Let's try this one. Okay, that's better. All of these fractions are going to be between 0 and 1. Okay, now, if I am thinking about turning all of these fractions into a denominator of 8, I'm going to set my line plot up in 8ths. Okay, and then I can add the other fractions just so we know. So in the middle, we're going to go ahead and put a mark, and I'm going to go ahead and divide these up. Now I have 4ths. If I divide them all in half again, I now have 8ths. Okay? So this will be 0/8. This will be 1/8, 2/8, 3/8. We'll switch sides. 4/8, 5/8, 6/8, 7/8, and 1 is the same as 8/8. Okay? So this one is easy. It goes here. There's 1 1/8. Mark it out. That's the, this one, 1 3/8. Mark it out. I've already put it up there, okay? My 1 goes here. Done. Okay? Now, think about these halves. We just said that those are the same as 4/8. So I have 1, 2. So those are just going to go here. Okay? Now those are gone. Now, 1/4 is half of half, right? If I have 50 cents and I split it in half, I have 1/4, 1/4. So half of this would be here. So I have 1, 2, 3, 1/4, which is the same as 2/8. Okay, 1, 2, 3. And I have these two left, and I know that 3/4 is halfway between a half and the next whole, so it's going to go here. So I have 1, 2. Okay? So I have just taken these fractions, I've given them a common denominator of 8, and I've organized them here. So I could go back in, let me grab another color really quickly, and say that this is also the same as 1/2. This is 3/4, and this is 1/4. I know it's a little messy up there. Sorry, guys. Okay, so again, this is way more complicated than the work you're going to actually do today. You're going to do the line plot practice that's in your math content on eClass. Print it out if you can. If not, just type your answers in your Google Doc. Please let us know if we can help you. And if this freaked you out a little bit, don't worry. I'm going to show you more about it on Thursday. Okay, guys? Have a great day. Let us know if you need help. We miss you. We'll see you soon. Bye, guys.